Okay, so as promised, we're going to do number 19 together, and then we're going to let you do number 20 and finish that problem out. So we have a table. It shows a car's value for 3 years after it's purchased. So the first year that the car, we have it, it's worth $10,000. The second year that we have it, it's worth $8,000. And the third year is worth $6,400. So starting with the rule. Okay, so we start with a ratio. So if we look, we have 8,000 divided by 10,000 is 0.8, and then 6,400 divided by 8,000 is also 0.8. So 0.8 seems to be our ratio here. All right, and then from here, we need our first term. So the first term, the first year, is 10,000. And so those are the two values that we're going to plug into our rule. So f of n is equal to the first term, 10,000, times the ratio, 0.8, raised to the power of n minus 1. So this is the rule, this right here, is the rule that you're going to use to answer number 20. Okay, so that's what you're going to use, and you'll plug in the value and figure out how much the value of the car is after 10 years. All right, so just a couple more notes that we need to take, and then we will be finished. So if you'll notice, arithmetic sequences were all linear functions, and so we really haven't talked about what this function is as far as a geometric sequence, but in your textbook you had several questions, and they were all graphs that you could see, and so hopefully you notice that the graph of a geometric sequence is not linear. In fact, it's actually exponential. So I wanted to take just a couple seconds, write a couple notes out about exponential functions, just to kind of give you an idea of what that looks like. So exponential functions, and we're just going to write a few notes here at the bottom in your summary section, are defined by an equation of the form y equals a times b raised to the x power. And this should look familiar because when we were working with geometric sequences, we had the y value is equal to the first term multiplied by the ratio raised to the power of n minus 1. So here we see that our exponential functions, that our geometric sequences are exponential functions. Okay, and this is just the general format for an equation like this, or for the graph like this. All right, and so what you'll notice is that if the b value here, and in your case the ratio, okay, or r as we've been talking about in geometric sequence, is greater than 1, then the function is an exponential growth, and it's increasing. Okay, so you'll notice that, for example, we could go back and look at number 17 here. You see that, oh, I'm sorry, number 15. Number 15, this r value is greater than 1. It's a 4. So what that means is that these numbers are getting larger, exponentially larger as we go. Okay, and so it's an exponential growth, and it's increasing. Okay, so then we look at what if it's less than that? So if b, or r, is less than 1, then the function is known as exponential decay. Decay meaning that it is decreasing. Okay, and so up here you see that the ratio is 1/2, that's less than 1, and so this number is getting smaller as we go. That 400 is reducing each time. Okay, so exponential functions are the same thing as geometric functions. If that ratio is greater than 1, the function is exponential growth. That means it is getting larger, it's increasing. And if it's less than 1, then it is exponential decay. That means it is going down, it is decreasing. Okay. And the last definition that we need here is that an exponential function has what we call an asymptote. It's an odd little word, kind of difficult to say. Okay, but all that it means is that there is a line which the graph gets infinitely close to, but it never touches or crosses. Okay, and so you'll see that as we start to work through some of these. If you look at the graphs, there will always be some line that the graph will get closer and closer and closer to, but it will never actually touch. And that's part of being exponential, is that they'll get closer to a value, but it's never going to get quite to that value. And that's what we call an asymptote. Okay. All right, so I think that's everything for our review. So now you just need to complete the evens. So that's 2, 4, 6, 8, 10, and 12 on the front side. And then you're going to complete 14, 16, 18, and 20 on the back. And then you're going to turn that in for a quiz grade. So just make sure you send it to me, whether it's an email, whether you drop it by the school, whatever it is that you need to do, make sure that I see that you completed those 10 problems and give you a grade for them. Be sure that you're concluding all of these notes as well, and if I wrote it down as part of the working out process, then you also need to write it down as part of the working it out process, okay? So just keep that in mind as you're working on these. All right, if you have any questions, be sure to let me know. I'll be glad to help in any way I can.